In this section, we are going to talk about triangle similarity. There are three triangle similarity theorems. We had many more for triangle congruent theorems, but now we are just talking about similarity. So we are talking about triangles that have the same shape but a different size. The first triangle similarity is angle-angle. If two angles in one triangle are congruent to two angles in another triangle, then the triangles are similar. For example, if you have two different triangles, but we know these angles are equal, and we know these angles are equal, then we can say the two triangles are similar. That's our first triangle similarity theorem. Our next triangle similarity theorem is SSS. Okay? And if three sides of one triangle are proportional, not equal, but proportional to the three corresponding sides of another triangle, then the triangles are similar. For example, if we have one triangle and then another triangle, if the side lengths are proportional, so if this is 2 and 4, if this were 3, then this would have to be 6. So we're kind of doubling these, doubling those. And if this were 4, this would have to be 8. So if all the corresponding sides are proportional to each other, then the triangles are similar. So the similarity ratios among all the sides must be equal. The third triangle similarity theorem is SAS. If two sides of one triangle are proportional to two sides of another triangle, and their included angles are congruent, then the triangles are similar. For example, if you have one triangle and another triangle, if these two side lengths are proportional and the included angles are equal, then we can say the whole triangles are similar. Okay. Our first example says, tell whether the triangles are similar. If so, write a similarity statement. All right, in our first example, there are a couple things we can mark. If these two side lengths are parallel, then we can say by alternate interior angles, those two angles are going to be equal. We can then also say these two angles are equal because of vertical angles. And then because we have two angles that are congruent, we can say the triangles are similar because of our angle-angle similarity theorem. Once they are similar, we are then going to write a similarity statement. So I would say triangle PTQ, and you can pick the first triangle in any order, but then you must match the corresponding parts. P matches R, T is going to match S, and then Q is going to match Q. And that would be our similarity statement. On our next example, we currently have a triangle, and the triangle currently has an angle of 43 degrees and 90 degrees. If you know that all three angles in a triangle add up to 180, the first thing I would do is I would get that third angle. So if you get the third angle in this triangle, you will get 47. And once you see that that angle is 47, you now know that these two right angles match. The 47s will match, and then you will also know that this angle will then be 43. So because of our angle-angle similarity theorem, we are going to say that these two triangles are similar. Once they are similar, we are going to write a similarity statement. So I'm going to start with my first triangle, triangle ABC. And once I have my first triangle written, I then have to match the corresponding pieces. So A will match D, B will match E, and C will match F. And there would be my similarity statement. On our third triangle, we actually have two triangles, but they're kind of pictured so that one triangle is part of the other. This would be my first triangle, and then this would be my second triangle. The first thing I would do is I would check to make sure the ratios are the same. So if you take your small triangle, this side length would be 2, and that would correspond to this whole side length, which would be 6. And if you checked the other side length, another set of sides, this side length here would be 3, and that would correspond to this entire side, which would be 9. And if you reduced both of these, they would both equal 1/3, which means we now have two sides that are proportional. Now, in order to use our SSS or our SAS similarity theorem, we now need to get one other piece. If you take a look at this little triangle and the big triangle, you can see they both share angle J. So by the reflexive property, we can say that angle J is equal in both of those triangles. So because of that, we have side, angle, side. So these two triangles are similar because of our side, angle, side similarity theorem. Once we have that, we can now write a similarity statement. I'm going to start with my small triangle. Triangle JKL is similar, and J is going to match J because those are equal angles. K will match M, and L will match N. So that would be my triangle similarity statement. In the next example, we are doing the same thing. It says tell whether the triangles are similar. If so, write a similarity statement and a ratio. So for this example, we have two triangles. And what we first must do is find out if these triangles are going to be similar. So what I would do is I would first take a look at this triangle right here. This is a 4, 4, 6, and then we have a 6, 6, 9. So if you take a look at your first smaller triangle, this is an isosceles triangle. I'm going to pick a side length of 4, and we're going to find its corresponding side, a side length of 4, its corresponding side, and then we're going to have a side length of 6 and its corresponding side. So because it's isosceles, we know the 4 and the 4 here must match the 6 and the 6 here. And then our third side, this 6 must match its corresponding side length, which would be 9. If you reduce all three of these ratios, you should get 2/3. Because 2/3 is consistent among the two triangles, we know that the triangles are similar because of the side, side, side similarity theorem. We found their ratio. We must now write a similarity statement. So I would say triangle PQR. Okay, so I'm going from P to Q. So we must match the 4 and the 4 must match the 6 and the 6. So P to Q is one of the two equal sides. So I'm going to say that P to Q is going to match P to R. And then PQR should match PRS. And there's our similarity statement. All right, let's check our next similarity statement. We have PQS and RSQ. And again, as you can tell, we have an isosceles triangle here and an isosceles triangle here. So the first thing we're going to do is match up the isosceles triangle pieces. So we have a 12, and an 18. And this 12 and 12 in this triangle must correspond to 8 and 8. And this 18 must correspond to this 12. If you reduce these, 8 over 12, 4 goes into the top one 3 times, into the bottom one twice. And if you reduce 18 over 12, it also is 3/2. So right there, we have our ratio. Because all three ratios were the same, we can say they're similar because of our side, side, side similarity statement. And then we can take and write our similarity theorem. So I'm going to go triangle PQS. So PQS, so I'm going to go in the order of the two congruent sides of the isosceles triangle. So I'm going to go from P to Q to S, and that will match from S to R to Q. Because these are isosceles triangles, both of these last two examples, the similarity statements could be written a little bit different and still be correct. On our last example, tell whether they are similar. So the first thing we're going to do is get our similarity ratios. 12 is the smaller of the two pieces, so that will have to match 16. 15 will have to match 20 if it were to work. If you reduce each of these, you will get 3/4. Because they both reduce to 3/4, we have a similarity ratio that is consistent. We then also know that these angles are equal because of vertical angles. So because of our side angle side similarity, we can say these two triangles are similar. We then must write our similarity theorem. So I'm going to say triangle TXU is similar. T to X will match V to X, and then we'll go to W. And that will be our similarity statement. All right, if you flip the page. On our next page, we are going to explain why triangles are similar and then find the missing length. The first thing we would have to do in these triangles is figure out why they're similar based on the information they give us. Right now, we know that these two angles are congruent. We also know that angle A is congruent in both triangles because it is shared in both triangles. So because of the reflexive, we can also say angle A is congruent to itself. So because we have two sets of congruent angles, we can say they are similar because of the angle-angle similarity theorem. We then must find CD. So, as you look at this triangle, the first thing I'm going to do is I'm going to find a side length on the small triangle, which is 9. 9 corresponds to the entire side length on the other triangle, which would be 12. And that is going to equal 5 on the small triangle over x. If you cross multiply, if you go 12 times 5, you will get 60 equals 9x. If you then divide by 9, x is going to equal 6.6 repeating. So CD will be 6.6 repeating. Our next example is very similar. It says explain why those triangles are similar and then find RT. Well, the first thing, if you look at these two triangles, is you can see that they share angle R. So you can say angle R is congruent in both triangles because of the reflexive. And once you have that equal, you can say that these triangles are similar because of your angle-angle similarity theorem. Once we have that, we then have to find RT. So first thing I would do is I would pick a side length on my small triangle, which would be 10, over this entire side length, which we will call x, equals, go back to your original triangle, 8, all over 12. When you cross multiply, you will get 8x equals 120. When you divide by 8, you will get x equal to 15. And once you get x, you then must plug it in to get RT. In this case, we called all of RT x, so we know that RT then will also be 15. On our next example, we have to find TU. And on this example, we know that the triangles are similar because of we have a congruent angles because of vertical. We have corresponding sides with a similar ratio, so we know that they're similar because of our side angle side similarity theorem. In order to find TU, they must give you VW. So in this case, since they did not give you VW, I'm going to tell you that VW is 10. Once we know that VW is 10, what we're going to do is we're now going to set up a proportion. We're going to call TU x. So we're going to say that TU is x. X corresponds to 10. And then we pick another side. I'm going to pick 12. And 12 corresponds to 16. Once we are at this point, we are then going to cross multiply. 120 equals 16x. And when we divide by 16, we get x equal to 7.5, which then means our TU will also be 7.5. All right, our last thing we're going to do is we're going to work on proofs. So just as we've done proofs in the past, the first thing we're going to do is we're going to write down our given. 3ut equals 5rt. 3vt equals 5st. We have our given. Then I have triangle UVT is similar to triangle RST, and that will be one of our similarity theorems. The first thing we must prove is we either must prove two congruent angles, or three proportional sides, or two proportional side and an included angle. The first thing we're going to try and do is we are going to try and get proportional sides. Based on this, what we can do is we can try and get side lengths that are proportional. For example, if I divide both sides by 3, and at the same time divide both sides by RT, what I then can do is get my 3's to cancel, and I'll be left with UT over RT equals 5 over 3. Now, our goal is to then get another proportional side that has the same ratio. So if you then take this example, and if I divide again by 3 to both sides, and if I divide by ST, I could then say VT over ST equals 5 over 3. Because both of my proportions equal 5/3, we can then say that those two sets of sides are proportional. Now, what is my reason for that? Well, if you kind of take a look at what I did to both sides, then what we can say is that they are equal because I divided both sides by certain numbers. So this is going to be our division property of equality. Once we have two sets of proportional sides, we must then look for an equal included angle or another set of proportional sides. Because in this triangle we have some vertical angles, I can say angle STR is congruent to angle UTV because of that vertical angle theorem. Once I know that vertical angle theorem, I then have two sets of proportional sides and one set of included congruent angles. So I can say the triangles are similar because of my side angle side similarity theorem. In my last example, I'm first going to start with a given. So I'm going to say BE and DE are parallel. And we're going to try and prove that triangle ABC is similar to triangle ADE. Alright, the first thing we would look at is if we have these two lines are parallel, we have a relationship between those two angles right there. So we can say that angle AED is going to be congruent to angle ACB because these are corresponding. So because my lines are parallel, my corresponding angles are equal, and we can say that is called PCA. Parallel lines mean corresponding angles equal. Next, if you take a look at these two triangles, in both of these triangles, they share angle A. So we can say angle A is congruent to angle A because of reflexive. Once we have two equal angles, we can then say the triangles are similar because of our angle-angle similarity theorem.